Okay, so this is day 2 of our 3.1 notes. Today we'll be talking about domain and range. Yesterday we talked about what domain is and what range is, so if you don't remember what definitions of those are, go ahead and watch the previous lecture or look at the notes that we've done in class. So, today we know that domain is going to be all of the possible input values and range is going to be all the possible output values. Now, when we look at a graph like this, typically, in fact, all the time, because we have an x and a y axis, domain is always going to be represented by x, and range is always going to be represented by y. So, the best thing to do here is let's start by putting down our coordinates. Since there's 4 points, we have to put 4 coordinates down. So, we look at this first one. We go 1, 2, 3 to the left. That is -3 for the x value. And we go down 1, 2. That's -2 for the y value. So we have -3, -2 for our first point. Now our second point, we go left 1, which is -1, and we don't go up or down any. So that's 0. The third point, we go over 1 and up 2. So 1, 2. And the fourth point, we go over to the right, 1, 2, 3. So we have 3. And we go up, 1, 2, 3, 4, a +4 for our y value. Now we have all of our coordinates. We just have to list our domain and range. So we look at our domain. I'm just going to draw a squiggly line, but we have to include, I believe on your keyboard, it would look more like that because this is a set. So we have to include those squiggly lines. So the domain is all of our x values. Let's write them in numerical order every single time. So the first x value we see is -3. So we have -3. We have -1, 1, and 3. Again, those all came from our x values, right? So our range is going to come from our y values. Let's start at the top. We have -2, 0, 2, and 4. It's as simple as that. We write down all of our coordinates. We put all of our x's in the domain. We put all of our y's in the range, and let's put those in numerical order. That means from least to greatest. Okay, now let's look at a graph that's like this. It looks a little different, right? We only have 2 defined points, so let's go ahead and write those 2 defined points down. So, in this one, in our x value, we go left 1, 2, so we have a -2. And we go down 1 for our y value, so it's -1. Okay, our second point. We go right 3, 1, 2, 3. We go up 2, 1, 2. So those are our 2 points, right? Now I know these cross in these points here, but we're not going to assume that those points are the exact points. Instead, we're going to write our domain and range as a compound inequality. As we've talked about before, when we're talking about an in-between value, so in this case it's from -2 all the way to 3 for our domain, we need to use a compound inequality. That's going to be an and compound inequality. So our domain is going to look like, let's put our lowest x first, so -2, put our less than or equal sign, put our x with our less than or equal sign, and put our highest x value, which is 3. That is our domain. So if you look at our x-axis, the one that goes horizontally, we see that from, that is a -2, all the way to 3 is our domain. Our domain runs from right to left, right? That means our range runs from top to bottom. So our range, let's look at it. Now, it's not always going to be represented by our coordinates. In this case, it is, but let's look. So the highest point our line goes is going to be 2 on the y-axis. The lowest point our line goes is a -1. So that means from 2 to a -1, or if we put it in numerical order, from -1 to 2 is our range. That's how high and low it goes. So we have -1 first, with the same exact signs, And our y, because it's the y-axis, and our highest value is 2. So our domain is from left to right. Our range is from bottom to top. So, if you have any questions, please ask me in class. I know it's a little bit confusing. Now, one more thing I want to add is the reason we have to put less than or equal to comes from our inequalities, is because we have a closed circle right here. Our second one comes from a closed circle right here. If one of those is open, you do not have to put the equal to sign. Okay, let's move on. This is going to be a monitoring progress. I want you guys to try it on your own. Go ahead and pause the video, and we'll go over it together. Okay, so hopefully you've done this on your own. The first thing that we're going to do here is write down all of our points. Let's start on the left side and work our way to the right side. So there's 5 total points. We have to have 5 total coordinates. Okay, let's start here. That coordinate is -2, 4. Let's go here. That is -1, 2. Here's our origin. Our origin is always 0, 0. Next, we have 1, 2. And finally, we have 2, 4. Now, there's going to be something just a little bit different when it comes to the domain and range here. So, I'm assuming a few of you may have written the range wrong, but that's okay. We're going to fix it. So, first, let's look at our domain. Let's look at all the x values. Let's start at -2 and go all the way down. So, we have -2. Next, we have -1. Next, we have 0. Then 1 and 2. Now again, the domain is all of our x values, right? The domain runs from left to right. Okay, now let's do the range. Okay. Our range has 2 repeating numbers. We have 2 2s and we have 2 4s. We do not have to write those repeating numbers down. Let's write it from least to greatest still. So let's go 0. Now, next is 2. We do not have to write a second 2. We only have to write 1 2. So that means the next number after that is going to be 4. So our domain is -2, -1, 0, 1, and 2. Our range is 0, 2, and 4. Remember, our domain is from left to right. It's all of our x values. Our range is from bottom to top for all of our y values. Okay, let's look at this one. This one might be a little bit more confusing. First, let's write down our 2 coordinates. The first coordinate we have 1. So go ahead and change that to 5, 4, which hopefully you've already done this before. We went over 5 and up 4. Okay. Our domain, again, is from left to right. So when we look, the farthest left our graph goes is 1, which matches our x value. So we have 1. We have closed circles. We put our x. The farthest right it goes is 5, which also matches our x value. Remember, our domain runs from left to right. We're always looking, how far left does it go? It starts at 1. How far right does it go? It ends at 5. It's as simple as that. The domain is as far left and as far right as we can make it. Now we look at our range. Okay, our range. A lot of you may have put 4 and 4. Unfortunately, that's not going to be correct because we look at our entire line, right? And our range actually runs from 0, because that's how far our line drops, right? And 0, and it ends all the way up at 4. So the highest it goes is 4, the lowest it goes is 0. So, in this situation, our range needs to start at the bottom, which is 0. We put our exact same signs, and it ends at 4. So that's the difference here. On this side, we're just worried about the individual points. On this side, we're worried about how far our line stretches. From left to right is domain. From bottom to top is range. Okay, let's move on. We are identifying independent, dependent variables. This you should have already learned in science, but we'll go over it one more time. Independent variables are variables that you can choose. You can choose to change them, right? And dependent variables depend on that independent variable. So, in this situation, our independent variable, we're looking at y, in fluid ounces of juice remaining, and x, which is gulps. So, you can choose how many gulps you take, right? You can't really choose how many fluid ounces are left without drinking it or pouring it out, right? So, our independent variable is going to be something we can choose, which is our gulps of juice. Our dependent variable is going to depend on the gulps of juice, which is the juice remaining. Okay? Remember, the juice remaining in our cup or our bottle or whatever always depends on how much you drink. You can choose how much you drink, right? Okay. Now we see here the domain is 0, 1, 2, 3, and 4. We have to find the range. Now remember, domain is input. Domain is also the independent variable. The range is the dependent variable. So whatever we're putting in is our independent variable. Whatever we're getting out is our dependent variable. So let's find our range with the domain that's given. So our equation that's given is y equals negative 3x plus 12. Go ahead and scroll down and give me some room. Okay, the domain is 0, 1, 2, 3, and 4. What is the range? The domain typically is represented by x, or the independent variable. We know that gulps was the independent variable, so gulps needs to be here. That's what we're putting in, right? And the amount of juice is going to be our y, because that's what we're taking out, or that's what we're getting out of this. We'll call it an experiment. So, in order to find our y's, we have to plug all of these in for x. So the first one, y equals negative 3. Let's plug 0 in first. Negative 3 times 0 is 0. 0 plus 12 is 12. Okay, our next one. Negative 3, let's put 1 in, times 1 plus 12. It may be beneficial to cross these off as you put them into your equation so you don't lose track. Negative 3 times 1 is negative 3. Negative 3 plus 12, or 12 minus 3, is 9. Okay, now we're going to use 2. We have y equals negative 3 times 2 plus 12. We've used 2, let's cross it off. Negative 3 times 2 is a negative 6. 12 minus 6 is 6. Now, let's put 3 in. Negative 3 times 3 plus 12. Cross that 3 off. Negative 3 times 3 is a negative 9. 12 minus 9 is 3. Now we have to do one more. One more equation because we have to put 4 in there. So y equals negative 3 times 4 plus 12. Negative 3 times 4 is a negative 12. 12 minus 12 is 0. Y equals 0. Okay, we have all of our y values. Now we just have to put it in our range. Now in this case, we have to write it in decreasing order because our lowest x started it off, and 12 represents 0, 9 represents 1, and so on. So let's do it in decreasing order. So our range is going to be 12, 9, 6, 3, and 0. It's a lot of work just to find the range, but as long as you know how to solve linear equations like we've talked about all year, you should be good to go. Okay, we'll move on to monitoring progress 4. You can go ahead and pause the video, read it, do it on your own. We're going to go over it together. Okay, we have a function which is a equals negative 4b plus 14. It represents the number of avocados you have after making b batches. Remember, a represents avocados, b represents batches, right? So in this situation, first we have to identify the independent and dependent variables. The independent variable is what we can change. Now, in your mind, you might think, well, we can change the number of avocados we have by going to the store, but we're going to pretend like we're already at home, because the number of batches you make kind of tells you how many avocados you're going to have left, right? And we can control how many batches we make when we're at home. So, the independent variable is going to be batches of guac. That means our dependent variable is the number of avocados we have left, because the number of avocados we have left depends on the number of batches of guacamole that we're going to make, because we can choose how many batches we make, right? So the number of avocados is always going to depend on the amount of batches we want to make or are going to make. So our dependent variable is the number of avocados. Once you know those two, we're able to find our range with the domain that is given, which is 0, 1, 2, and 3. So remember, B represents batches. Batches is our independent variable, so we're going to plug it in for B to get the number of avocados left after we make a certain amount of batches. So let's go ahead and do that. I am going to write my equation up here and scroll down. A equals negative 4, B plus 14. Okay, again, our domain starts with 0, 1, 2, 3, and we have our equation, which is A equals negative 4b plus 14. Remember, we are plugging our independent variable in to get an output, which is the number of avocados. So we look, the number of avocados, which is A, equals negative 4 times 0 plus 14. So we look, negative 4 times 0 is 0, 0 plus 14 is 14. Our second equation, A equals negative 4 times 1 plus 14. Negative 4 times 1 is a negative 4. 14 minus 4 is 10. So that tells us right there, if we are making one batch of avocados, we are using 4 avocados, right? Because 14 minus 4 is 10. That means we have 10 left. Now let's do another one. We have A equals negative 4. What if we're trying to make 2 batches of avocados? Negative 4 times 2 is 8, so that means we're using 8 avocados of our 14 that we had to start with. Negative 8 plus 14, or 14 minus 8, is what? 14 minus 8 is 6. Okay. Now, what's next? A equals negative 4 times 3 plus 14. All right, you have 3 batches of avocados now. Negative 4 times 3 is a negative 12. 14 minus 12 is 2. That means after making 3 batches of avocados, we have 2 avocados left. Or 3 batches of guacamole, I should say. So we've learned several things. First of all, we've learned that it takes 4 avocados to make a batch of this guacamole anyway. And we know that we need to only make 3 batches. 14 will only give us 3 batches of guacamole. So let's write our range from what we have. We have 14, 10, 6, and 2. Remember, 14 lines up with 0, 10 with 1, 6 with 2, and 2 with 3. So let's write it in that order. Range equals 14, 10, 6, and 2. So that is our range. Remember, it's a lot of work to get to the range, but if you know that you just have to plug those in for x or whatever variable you're given as your independent variable, then you can find your range pretty easily.